All right, here's our second video on confidence intervals. It's very, very similar with one tweak, so it's going to be a good refresher, and I think it's going to be shorter than the last video. If you want to, while I'm discussing the problem, enter these numbers into a list into your calculator, that would be good. Otherwise, you can pause as well. So here's the problem. Your company sells exercise clothing and equipment on the internet. To design the clothing, you collect data on the physical characteristics of your different types of customers. Okay? You just want to gain information. So maybe you're figuring out the weight of 12 males, and you want to at a particular height. I don't know. You're trying to do something to figure out how big you should make your clothing. So you take a sample of 12 runners. I'm going to tell you, let's suppose that it is random runners, okay? And here's 12 of them. And we want to construct, and I thought I had another one on there, maybe I didn't. We want to construct and interpret a 99% confidence interval for the mean weight of runners. Okay? We want to construct and interpret a 99% confidence interval for these runners. Okay? So we want to figure out what is the average weight of these runners. I'm sure there's a lot of runners out there, so there's no way we're going to get all the runners onto a scale and figure out the exact average. So we decide, you know what, let's just take 12 of them and let's see if we can figure out what the average is, at least close to, by only taking 12. Here we go. Step one is give it a name. We only have one. Okay, it is one sample. We took a one sample. And is it a mean problem or a proportion problem? Okay, it is a mean problem. I'm sorry, I forgot to write it there. It's construct and interpret a 99% confidence interval for the mean weight of runners. So it's a mean problem. And if it's a mean problem, write this letter T, one sample, T interval for the mean. And that's all step one is. Boom, give it a name. And we only have one so far, so there it is. One sample T interval for the mean. Step two, conditions. Conditions. Where did I get these 12 runners from? Honestly, the problem doesn't say. It better be random, otherwise there's a big problem. So if it doesn't say, then we can just say assume a simple random sample. Tell me, the grader, tell AP that you're looking for a random sample. Okay? Assume a simple random sample is a good way to do it. If it is a random sample, then you write simple random sample stated. Then the other check is it normal? Well, hopefully there's a big siren going off saying, uh-oh, we only took a sample of 12. 12 is not greater than 30. I can't use the central limit theorem. You're right. I can't use the central limit theorem. And that's the only thing that's really, there's a button on your calculator that's a little different. So what do we do if we don't take a sample that's greater than 30? We have to sketch a graph and see if it is roughly symmetrical. So I'll show you. Hopefully, enter the numbers into your calculator. So hopefully you enter numbers into your list one here. And then we're going to make a box plot. So you go second, y equals. You go to plot number one. You're going to make sure that's turned on. Then we're going to go and make a box plot. I put my numbers into list one. Hit graph. If you can't see anything, hopefully you remember from chapter or from first semester, to hit zoom 9, and there it is. There are two things we're looking for. is number one, are there any outliers? If there are outliers in a group of 12, that's a big problem. Okay? There are no outliers, so that's good. There's no like dots by themselves on either side. And number two is there any major skewness? Or does this look roughly symmetrical? This looks roughly symmetrical to me. Okay? So what do? You want to copy, just make a sketch of this on your paper. Okay, you want to make a sketch of this on your paper. And AP wants you to put a couple of numbers. So we're going to put the lowest number and the highest number. So we're going to hit trace. And down below, we'd want to write, 53.1. Okay, 53.1. And then over on the right-hand side, we want to write 69.2. So we sketch our graph. Looked, something like that. Looked pretty symmetrical. You want to write your number. I forget what it was. Write your number there. Whatever that is. And then you want to talk about the graph. You want to say, you know what? It looks pretty good. There are no outliers, which is huge. If there's an outlier in a group of 12, that's really bad. There are no outliers. It looks roughly symmetrical. And that is our normal check. Okay? If there's a sample of 80, then you can use the central limit theorem. But if it's less than 30, then I need to graph it. Sketch the graph, put a couple numbers for scale, and comment on the graph. Cool. Step 3 is calculator step. Get some numbers. Okay? Calculator step. Here we go. Hit stat. Go over to tests. There's only one that we have. It's a one sample t interval. So that's number 8. Hit enter. Hit enter. Come on now. There we go. Last time we entered in the average in the sample standard deviation. We don't have that. We have a list of numbers. So we go over to data. Sorry. Hit enter. And then we tell it what list to go from. So I put it in list 1. Go list 1. What confidence level? I believe I said 99. So hit 0.99. Hit calculate. Bada bing, bada boom. 57.59, 66.44. 57.59. 57.59 to 66.44. 66.44. Okay, that's how. Step 3 is, can I use my calculator correctly? Step 4 is my sentence. We are 99% confident that the true mean weight of runners is between 57.59 and 66.44, and I think it was using kilograms. And that's a 4-step process. Okay, I'm not going to go into any more explanation about things. Boom, that's beautiful. 4 steps, 1 sample mean. I have a joke, since we were talking about runners. I like this one. This is new to me. What do sprinters eat before a race? Nothing. They fast. Ha ha! Have a good one.